Here we go.
Hello, everyone. Welcome to a stability chamber problem, how to analyze and remediate problems in stability chambers. This is a Stability Hub webinar sponsored by Parameter Generation and Control. We really appreciate them joining in today. Our program is based on the Stability Hub November newsletter article by the same name, written by Jeff Carr, and he's a contributing author or stabilityhub.com. Geoff Cook of Parameter Generation and Control will take us through the main points of the article and then expand our discussion to stability chambers in general. All are welcome to comment or ask questions throughout today's session by using the Zoom chat feature. If necessary, we can unmute and go into further detail if we need to. Joining Jeff on our panel of subject matter experts are Walter Routh, founder of Sagana Consulting, and myself, John O'Neill, editor of StabilityHub.com and founder of Pharmaceutical Stability Discussion Group. Jeff, the program is yours at this point.
All righty. Thank you, John. Welcome, everybody. Thank you for joining. So yes, today we are going to be discussing the article that was published recently and just going over some general key points in stability. So one of the things I wanted to start out with is just a quote from our service manager, Jeremy, on the importance of preventative maintenance. It can just never be overstated. A lot of times, an environmental control unit, especially on a walk-in chamber, will be placed in an interstitial space or somewhere where it's easy to forget about. And, just the preventative maintenance will allow you to keep tabs on your equipment frequently to be more familiar with it for when something goes wrong, but also to prevent it from going wrong. So I'm just going to read Jeremy's quote here that you can all see on the screen. Testing and studies can be significantly impacted by various factors, but a common issue is the lack of preventive maintenance on the temperature and humidity chamber. Regular maintenance is key to avoid downtime and protect products and test results. So a key theme throughout this will be not just the product, but also the results of the testing and the retention of all that data. So this is just an introduction for myself to give you all an idea of who I am. I started here at Parameter about 8 years ago in our test department as a testing technician. Setting up all the machines, we test 100% of every machine that we build to the entire range that it's capable of doing. So after working in the testing department for a while, I helped develop our service department, answering the calls, helping people troubleshoot issues over the phone. And through that experience, really gained a lot of knowledge on the subject matter of today's presentation. So then I became the operations manager, and about 2 years ago, I became the operating officer. I went to the University of Tennessee, really enjoyed engineering and geology. Got into electrical circuit analysis a few years ago at Parameter, as well as computer programming, and I've just always been interested generally in philosophy and business management. And then recently in the new role as the operating officer, we at Parameter are going through a pretty significant and aggressive lean manufacturing transformation. So just a bit of background on myself there. Today, we're just going to be introducing the problem, going back over some of the things that the article stated. We'll look at the problem in further in depth and sort of analyze a root cause and go over some corrective actions and how those can be properly documented for regulatory compliance. You always want to use, your good documentation practices. A lot of this stuff will be reviewed in audits depending on the severity of the issue. The last slide, just encouraging questions, but I'd like everyone to just be encouraged to ask questions throughout the presentation. Throughout the slides, I sort of just threw in some seed questions to get some conversation going. So if anyone is interested in taking any of the topic matter further throughout the presentation, feel free to. So a review of the problem, just to get started, is how critical the role of stability chambers is in medical product development, all aspects of medical products, from pharmaceuticals to medical devices. But stability chambers, they're essential in product development and storage. We control temperature and humidity, and sometimes even light density and saturation to very precise conditions. Um, you know, one of my seed questions here is to encourage you guys is a question we get sometimes is in what way do the stability chambers contribute to the product development? Obviously, regulatory compliance. You want to make sure that the products being developed are consistent in their quality, consistent in their optimization to ensure their stability life and shelf life, not just longevity, but also in different environmental conditions throughout the world. So you want to make sure, a product is not going to dissolve after sitting on the shelf in a rainforest climate after a number of years or anything like that. Beyond the product itself, one aspect that I find that is often forgotten in the utilization of stability chambers in medical product development is the packaging itself. The packaging that medical products are contained in is needs to protect that product from light, from being damaged in travel. So there is quite a bit of packaging validation that goes on with the critical role of stability chambers. So going back to the original problem, why did the chamber flood? So if you guys will recall from the article, the stability chamber was running a very hot and humid condition. We sometimes call it a rainforest condition. It's pretty extreme. It is 40 degrees Celsius at 75% humidity. That is a very common regulatory compliance condition for environmental control units to test product to. But the root cause of why the chamber flooded was actually that the heater had failed. So oftentimes you will think you see water everywhere and you will be looking for the source of the water. The source of the water is actually just the atmosphere and how much water vapor is contained in that hot and humid atmosphere. The environmental control chambers are often vapor tight to maintain that stable atmosphere. So therefore, as the temperature drops in that vapor tight atmosphere and chamber, the amount of water vapor that's in the air remains the same until the room temperature drops below the ability of that air to hold the water as vapor. That is the dew point of the temperature and saturation of the air. And that water vapor actually begins to condense out of the air. So it's sort of like rain. It's sort of like a storm of just dew point and water condensing on everything inside the chamber. Again, one of my cedar questions here, just to kind of encourage conversation. If anyone has different questions or a different take on it or has experienced anything like this, feel free to, contribute to the conversation. But, the nature of the flood is more like a full room saturation. The concept of dew point is a little hard to wrap your mind around, but as the room temperature drops below the dew point of that air, the air just loses its ability to hold the water vapor as moisture. And so the water vapor condenses out of the air throughout the chamber, covering everything in dew. So on the graph that's on the screen, you can see the percentages of relative humidity on the colored curves. 75% at 40 degrees humidity, 40 degrees Celsius temperature, 75% humidity, excuse me, would fall between the green and the red line. And then simply as you move horizontally down the temperature axis, you would cross that dew point of 100% saturation, at which point water would just condense out of the air onto the product, onto the packaging, even inside the packaging sometimes, depending on the permeability of the packaging.
Hey, Jeff, just before you go on, John O'Neill here. Just wanted to comment, there are some other causes of floods. This one's the most scientific one I've seen. Other ones are more haphazard in maybe in preventative terms. There could be other sources such as overhead pipes have done in my stability samples at one point where they started leaking. People have noticed that there's been hurricanes recently in the southeast, and there was a notable one in New Jersey once that put a deluge down on a parking lot that sloped down towards the building. The stability chambers were located in the basement, and the entire basement was flooded out. I think that was the epic flood of my lifetime that I knew about. Also, improper cleaning procedures where somebody goes in with a bucket and sloshes water all over the chamber here and there. So just a few others that happened. But I really like Jeff's example here because it's much more scientific and instead of disastrous.
All really good points there, John. And if your first inclination is to just look for a source of physical water. It's a little, you'd have to get pretty far into the root cause investigation to get to the point that you determine that the water condensed out of the air. But if we take the condensation consideration a little further, if you do have a vapor tight chamber, even if the heater is working fine and the chamber is working fine, if the door is left cracked open a little bit, as that hot, humid air from inside the chamber escapes into the ambient temperature outside the chamber, you can potentially flood a lab space or the area very close to the outside of that chamber. So the concept of the dew point extends even outside the chamber. We see that fairly often.
I have a question to ask too. Is the basis of the question is, what are some minimum expectations for preventive maintenance from an auditor or from an inspector? In other words, if an inspector asks to look at my program, what will they be looking for? And I think the question applies to this because you're saying the heater failed. Could preventive maintenance have prevented that? And I think, what's an auditor if they look at your investigation on this and say, well, why did your heater fail? And that's where this question comes from, is what would an auditor expect of my preventive maintenance program?
That's a very good question, Walter, especially your use of the word minimum required maintenance. From my understanding, you can write your own preventative maintenance SOPs as long as they uphold the auditor's expectations. I'm not incredibly sure, and it may even sometimes be a bit subjective on how you determine that minimum requirement. At the very least, the entire inside of the chamber should be, inspected and cleaned. I would hope that a heater, with a risk of imminent failure would be observed through that process, and you could note that it may need to be proactively replaced to prevent that failure. One thing that Parameter does that we pride ourselves on is we take our preventative maintenance a step further, and we actually simulate the heater. We run it to 100% and then back to 0% very quickly. It does not impact the room temperature or humidity at all. It just allows us to take amperage readings of the heater at 100% output and 0% output and just confirm that it's operating properly. And through those readings, you can sometimes determine that a heater at 100% output is drawing way too much amperage and will fail imminently. Just go ahead and proactively replace it. Another really good thing to keep in mind is holding spare parts on hand. We like to keep prioritized spare parts list based on the risk of the component failure, but also the impact and frequency of that component failure. And a lot of components have expected lifetimes. So you can keep some spare parts on hand, based on the expected lifetime of that part and also the risk and impact of a failure.
Thank you.
So we'll keep on going through the slides, you guys, but certainly anyone throw any questions out here that you would like to. This is just a whole list of immediate corrective actions. Very often when a failure happens on an environmental control unit with pharmaceutical product inside, it is an all hands on deck emergency situation. One of my biggest suggestions to get ahead of a failure is have a contingency plan. Know who the responsible parties are and what the reaction is going to be. You want to know what the steps are, who you're going to call, and how it's going to work before it happens so that the whole process of it happening goes smoother. Obviously, the first thing you got to do is you got to do an investigation and a root cause analysis into the nature of the problem. Again, I've got their failure preparation. That's the spare parts and contingency plan I mentioned. The detection and notification is sometimes if you are actively monitoring your chamber, or you can, we are developing future products that will actively monitor the health of the components in the chamber as far as detection of the failure. The CAPA and remediation goes more into the regulatory compliance and data retention and good documentation practices we can get into a little later. But you want to make sure that any of your immediate and corrective actions are well documented so you know what was done. Sometimes if you are not prepared with a good contingency plan, your immediate corrective action might not be based on a fully carried out root cause. And you could replace a part, expect everything to go back to normal, but your root cause wasn't thorough enough, or there was just a mistake there, or you could have an additional component failure based on the first one. It can get pretty deep, but you want to have all of that pretty well documented so you can always see the trail of fixes and repairs done to the chamber. The procedures of misaligned with successful operation. Again, you want to have established procedures for how to operate the machines that include these contingency plans and make sure that all your personnel are trained on that. The monitoring response can be poor if you don't have a good contingency plan. In these situations, it's all hands on deck. There's millions of dollars worth of product in the chamber. You're in the 4th year of a 5-year study and your chamber goes down. So be sure that you have a response plan and everyone's trained on it. Sometimes we see that these products can be in areas that have personnel access that shouldn't really be there. And some of these chambers have bright, pretty controllers on them that are just hard not to touch. So ensuring that security and everyone with access to the area understands the importance of that. The proper preventative maintenance we went over pretty well. If anyone has any questions on that, I'd encourage you to ask now or follow up. Our service manager, Jeremy, is on here and would love to help field any of those. The external chamber environment is a factor that is also easily overlooked. A lot of these chambers are operating at very precise temperatures and humidities, and those precise conditions are contingent on the chamber itself being in a well-conditioned area. So sometimes the ambient temperature outside of that area, and sometimes even the ambient humidity outside of an environmental control chamber can affect the humidity inside the chamber depending on how well the vapor barrier is sealed. We went through procedures a little bit and the training of personnel. Monitoring the chambers is something that's very important. Our older chambers have a PC software that interfaces with them. We have newly developed a controller that you can simply plug an Ethernet cable into, and it will communicate with your building monitor software. And then having secure measures to keep your chamber limited access to only the personnel that understand how to use it. So the water damage, in the scenario described in the article, there was water damage to the packaging, and if it seemed like a rainstorm or a localized leak caused by a leaking pipe or a flood, you might expect to see more localized water damage. So you'd be able to kind of trace the water damage to the source. In the scenario described in the article, it's kind of very puzzling to open an environmental control chamber and everything on the inside of the chamber is saturated. So I went over the 40C at 75% humidity is an extremely hot and humid condition. If you've ever been inside of a chamber, we do make the walk-in chambers. Going inside a 4075 chamber is not terribly comfortable. It is like stepping inside of a rainforest. So there's significant moisture content in the air. And as the room cools, the cooler the room gets, the more moisture is going to condense out of that air. And it can just fully saturate a chamber to where there could be an inch of water on the floor, as well as on every bit of your packaging, of the shelving, of the lights, inside the light. So anywhere that atmosphere is 4075 and cools below that dew point will condense water out of the air and cover just everything inside the room, inside the packaging with moisture. So back to the root cause and corrective actions. I might let Walter and John chime in here a little bit as far as regulatory compliance and data retention. That is a little bit out of my realm of expertise, but in my time with the service department, I gleaned that it is incredibly important. It's not important just to get your chamber back up and running. It's very important to document all the steps that were taken to get it back up and running, as well as the steps you're going to take additionally to prevent it from happening again, and sometimes even a contingency plan to deal with it happening again. So there are numerous guidelines and standards across different countries and continents. Some of them are harmonized, but obviously the FDA has their own. There's the European Medicines Agency, and there's the International Council for Harmonization. But Walter, if you or John could speak a little bit on how good practices guide the documentation and data retention of such a failure.
I'll yield this one to Walter.
Well, you obviously have a significant excursion. Unfortunately, you could have the case where, I mean, I don't know, I don't recall having a procedure where you're not allowed to have a flood in your chamber. That seems like an obvious condition, but and then again, you might have a requirement that excursions have to be greater than 24 hours before you have an investigation. So you could have your door or your heater go out, temperature drop, a flood, and then back up and running within a few hours and not have a situation. However, no matter what, I would think, you've got stodgy secondary packaging at the very least. So you would need to investigate. So you've got an investigation, you're looking at root cause, you do your PMs, your preventive measures and all that. So you should, with a common investigation, you should end up handling the whole situation. An auditor would look, see you've identified the root cause, you fixed the root cause, and they're not going to be that concerned with what the results are. That's the plant's problem, the company's problem. Now, the good news is you're in an accelerated condition already, so you're expecting some change. The real question would be, is this excess moisture really going to impact your probably already tightly packaged product anyway? So, you could, in your investigation, rationalize continuing the studies as is, because if you do end up with failures, you were at accelerated already. If you don't have any failures in the end, which is still highly likely, because it was only a 1 day or probably a relatively short exposure to moisture, you may end up with no failures, and you can say, well, that was worst case scenario and we're still okay. So those kind of rationales can be built into your investigation. So it's not really what the auditors think, it's how you handled it, how you handled the preventive actions and identified root cause, and what you did to keep it from happening again. That's what they're going to be looking for.
I'll just throw in that if you have one of these cited in a 483 for lack of your impact evaluation or adjusting a study if it was called for, improving your chamber care, any one of those, all the way through to lack of improper preventive maintenance, a repeat 483 is not good. So it's significant. If you have any one of these, you don't want to let it go, even if it's a matter of money or resources. You need to find a way to deal with that. We do have a chat question that asks, in this example, was there a temperature alarm prior to the discovered flood? The answer to that in the article, yes, there was. It says that there was a response by a metrology associate. He urgently attended it, and he found that the heating system had failed and temperature had decreased, and more seriously, the chamber was flooded. So apparently, in this scenario, it happened quite quickly, but yes, there was an alarm. That was great. So a temperature dip is one thing. I've also seen alarms where there might be a moisture detector sitting on a shelf or the floor. And if you get a puddle or something, it closes the circuit and sends out an alarm that there's definitely a water condition in there. And that was years ago that we had that kind of technology. I'm thinking by now it must be much more sophisticated that you can detect those things a little bit faster than our old-fashioned floor alarms that we used to have. So hopefully that answers your question that yes, there was an alarm prior to the discovery, and it was the alarm that caused the person to discover it. There's a follow-up one. What is the industry standard amount of time for the chamber to be out of spec where there is no impact to the studies? And that's an interesting one because officially, for a commercial product, you could be out as long as 24 hours. I've always had a bone to pick with that particular one because there's a difference between being out by a few degrees off of room temperature for 24 hours and being off of 4075 for 24 hours, a major impact. There's nothing in the guidance that says that you couldn't put your samples on a rocket ship, control the conditions, and send it out to the sun and bring it back in less than 24 hours if it was feasible to even do that. And you don't have to report any excursion because it's less than 24 hours. So there's a flaw in the thinking of just making it time. I think you have to have some rationale. What's the amount of time that you're willing to say your product is good? A lot of companies will put on maybe an exemption that a chamber can go out for 20 minutes, half hour, even up to an hour before they start taking action. So again, with justification about the nature of your products, I think you need to determine that. But so an industry standard is going to be less than the required amount of time in the CFRs or the federal regulations and guidance is 24 hours. So I would hate to rest on that 24-hour thing without a really good justification why I waited that long. Walter, any comment on that?
Yeah, I completely agree. The in a past life for us, we had a graded scale where there were certain amounts of time given for the severity of the excursion. So we were allowed up to 24 hours if it was less than 2 degrees and I believe less than 5% humidity out of range for less than 5% humidity. Um, we also had one, where I think we had 2 hours if it was greater than five. And depending on the temperature as well. I mean, if it was a minus 80 and it's going 10 degrees out, it may not matter as much. So we built a pretty detailed procedure around that. It was based on not based on scientific evidence, but based on kind of logic and just. But to be honest, for several, I mean, over 10 years, we had that in place with no issues with an auditor. Um, just as an aside on that.
And for me, Walter, one of the most significant things he pointed out was that you guys had a plan. Because Jeremy Jackson, our service manager on this call, can definitely reinforce that it is very difficult for Parameter to get a Parameter certified technician to a customer's facility within 24 hours. We do have, a service network all over the country, but getting a response time like that is difficult. So having that contingency plan in place and having that familiarity with your own equipment is very important.
Yeah, and on that, Jeffrey, I would just like to say that usually in the beginning stages with customers from the sales side of it, and when we start the project, we want to start working on those plans at that point in time, getting personnel trained that can respond immediately, because there are times that we cannot make it in that timeline. So we would want to get ahead of that at the beginning stages while the unit's being built before we ever even get on site.
Yeah, this is where having a backup room, ideally, or something that can be brought up to speed quickly, at least. We did have a procedure that allowed us to move material from one chamber to the other, and if within a specific time frame, it would not require an exception event. It would just simply documentation of the inventory move and such. But
Yep. And, beyond the backup room, Walter, we do have several systems that are just fully redundant units that speak to each other and monitor each other. And one unit has a heater failure. the other unit's notified immediately and begins to warm up and transitions to take control of the room. The customer gets a notification of a failure. The room never experiences maybe even an out of spec condition.
Well, thank you, audience, for those questions. Keep them coming. Anything that comes to mind, you're welcome to put in there as Jeff continues.
Yep, certainly, you guys. I'll continue. I only have a couple more slides, and I kind of raced through the first half of them. So, I would just iterate here with the corrective actions on the screen that Jeremy and I are very familiar with the corrective actions and the procedures that our customers have to go through. So not only do we, build and service the units, but we're very happy to help with any cause and preventative action, contingency plans. We're very often filling out A3 problem solving reports and things like that. So beyond just the service alone, if there's anything or questions that we can help field in regards to the documentation of all of that, I'm always happy to help. So the prevention and final thoughts. Again, I've mentioned several times the comprehensive plan. Just cannot reiterate that enough. Even if it's not a preventative maintenance plan, as long as it's a contingency plan in the inevitable instance of a component failure. We have good documents on the expected life of all the parts, the motors, the pumps, the heaters. The life of those parts is often dependent on the conditions you're running. A 4075 chamber, it will deteriorate some lesser metals over the course of years, over the course of studies. So it's very important to note all that and plan for it ahead. Documenting the entire scope of that plan, of the response, the responsible parties, and who's supposed to do what when, and even sometimes the scope of parameters involvement in that plan. The stakeholder responsibilities can get very muddied in the instance of a component failure during a pharmaceutical product development study. So it's very important that everyone's pretty clear on who's supposed to be doing what and when at that time. And the data integrity, I went over just a little bit. We're very excited about the Ethernet connectivity. Our new controller will communicate a plethora of variables. I think it's something like over 35 variables through Ethernet to a wide range of softwares that can interact with it. It's basically just like a set of Modbus data IP addresses that you can correlate tags to. But that will monitor all the chamber deviations. You can set the alarms. Going back to the alarms comment and question, it's very important to consider your alarm trip limits and the timers that you place on those alarms. You might want a 4075 condition to be more closely monitored and alarm you sooner. You may end up with some nuisance alarms based on door openings and things like that, but that may pay off in the long run just to be notified a little sooner. The real-time chamber inventory is maintained. The procedure for product impact evaluation. Walter, very good point about the product itself typically being already packaged in a vapor-tight container. A lot of times I neglect to really think about the product that's inside the chamber because I'm so focused on servicing the chamber and getting it back up and running. So good perspective there. And then continuous improvement, issues will always happen as much as we plan for risk mitigation and contingency. Learning from all the things that do happen and bettering those contingency plans. So yeah, guys, my next slide is questions and answers. If anyone has anything to throw in here about the entire article or how we can further discuss the dew point control, happy for open discussion.
Thank you, Jeff. We'll continue to watch the chat and audience throwing questions in. Over the course of several seasons, the Pharmaceutical Stability Discussion Group has had a wealth of questions around the kind of issues that you discussed today. I'm really surprised that maybe there's not a certification of people that know about stability chambers and can be an asset to your stability group from the knowledge that they've gained from these kind of courses and participating in that. So there are more things that have come in, and if as soon as those dry up, I'll read some of those other questions that would be really informative about stability chambers and some of the situations that we run into. So this one asked, if there isn't a backup chamber of the specified conditions and the samples are moved to a less stressful condition, does it make sense then to adjust the pull windows for samples in that chamber? I'll give an answer and let others comment as well. And yes, this is a common practice. You want to make sure that you do it on a scientific basis. So if your temperature has come down from let's say 4075 and fairly quickly leveled off at room temperature, you can measure the amount of time that you lost in your pull window and extend that, but fully documenting and giving justification as to why you did it. There are other less clear situations where it might have come down very slowly from 4075 and maybe hovered at 30 something for several days. That's a bit more complex. I would really want a statistician and some other folks that from the analytical lab to give me a really good evaluation of how much time might have been lost off of the so-called stability budget, the amount of time that was expended, even though it wasn't at the listed condition. So a quick answer, yes, and a caution to make sure that it's fully justified with statistics and science to do that. Walter, any other comment on that?
Yeah, especially if you're in a commercial situation where you've got a regulatory commitment and now you're possibly not meeting that, or what you've committed to is changed. Um, Again, you can justify it, especially in your exception documentation, and explain why it's a good idea. However, my big caution is that by doing this, you really highlighted the fact that you had no other options, no backup, no secondary carrier or supplier that could take your samples. And I think you would end up with an observation from an auditor for having a uh, uh, for just not being ready for this situation and not having a contingency plan.
Mhm. If your budget is limited for a number of years, then I find not only myself, but other people in that situation where you wish you had that. And this is a good case to make for with your management that you really need to do this so that you're not put in this particular situation. So kind of a worst case scenario. Let's see, another one. What do you find to be the most overlooked aspects of operating stability chambers?
The
So this would
most
be,
overlooked aspect, from my perspective, would be familiarity with the machine. Um, Parameter machines in particular, I feel, are not terribly complicated. Just knowing that you can open the machine. If you call our service line, there are three folks that will personally answer the phone, Jeremy Jackson being one of them, and would be happy to get you familiar with the machine. Um, but oftentimes the machine may be above a drop ceiling or in a mechanical space that the operating lab technician does not have access to. And in the event of a failure with the 24-hour window that you have, finding the person that has access to that area, or getting someone on the phone that knows how to even look at the machine, can take eat a lot of that window away very quickly. In the event of the heater failure, knowing how to navigate the machine's controller and checking several of the various parameters that you can see in the user interface. Most failures can be determined by taking a few data readings from the interface. And that way, through your familiarity with the machine and how it works, you can know within an hour the parts you need, the service you need, or what your mitigation plan will be.
thank you. There was a follow-up to that last question before this one. I started talking before it actually popped up. So let's go back for a second. in considering there's isn't a backup chamber and you're moving samples to less stressful conditions. When adjusting the pull windows, would it be just for the first pull window or for the entire window? I'm thinking just off the top of my head, it would push everything back because your timing would be different. It still impacts the samples for the entire length of the study. Walter, any comment on that part?
Uh, Not really. It just all comes down to how you justified it. But I agree. I would expect that, if if one interval shifted, all of them should have shifted again, unless for some reason or some way you can justify not doing that.
Okay. I'll move to another question. Are there
Well,
ways
John,
of
just to go back
determining?
to
Yeah.
the comment on the one of the most overlooked aspects of humidity chambers, Walter, if you could speak to how critical preventative maintenance is. I know you always had a great preventative maintenance plan in place, and I feel that may have, limited the excursions that you experienced with your environmental chambers.
Yeah, well, it helped that they were also new, but we had okay, fine, I'll say it. We had you guys. Um, it was great. We was kind of a um, forget it. You guys came in every 6 months or year, depending, and it just seemed like we never had any issues. It worked out very nicely. Um, at some point, I think we ended up training our own maintenance people to be able to handle that. That's what I've heard since then. So, um, either way, though, the having the very detailed things that need to get fixed or need to get checked to prevent an outage is quite critical. So,
And that's a great segue into the next question. And this is assuming that you don't have the person who sold you the chamber team to be able to jump up and repair or do preventive maintenance. The question is, are there ways of determining if an outside contractor is as qualified to maintain chambers as an in-house organization? So in particular, if you're in a remote area, there's not necessarily a great big chamber company there or a calibration and validation company nearby. There's a local refrigeration company or something. How can we determine whether or not those folks are qualified? Is there some kind of certification or experience that we would be looking for that would give us some kind of confidence in that?
That is an absolutely fantastic question, and one that Jeremy and I wrestle with ourselves. Um, you never know. Obviously, you can look at reviews and try and find someone reputable. The nature of how precise environmental control units operate is beyond a lot of residential refrigeration mechanics and techniques. There's different circuitry in the refrigeration line. Often the dew point control theory is so much different than the air temperature control understanding. I would say the easiest way is just to heavily utilize the service support of the manufacturer of your equipment. We pride ourselves very much on answering the phone personally. Whether it is you, the owner of the equipment, or your service provider, our phone support is free and we're happy to give it because we just want our customers to be happy with our product. But we have fairly well written operations manuals that include the troubleshooting sections. Those are always very helpful to keep on hand and readily available. I find that they are often overlooked or lost fairly easily. So just knowing where your operations manual is and being able to provide that to a contractor is incredibly valuable. We have over the years built a fairly extensive troubleshooting guide that we use in-house for our phone personnel. So whether it's you or the contractor, you can give us a call and we'll be happy to answer the phone. There's oftentimes that I get on the phone myself and help troubleshoot if Jeremy's taken up by other things. So the biggest thing I would say about vetting an outside contractor is just making sure that they're willing to dig into something that they don't understand, but also ask for help and not assume that they understand it. We are always happy to provide the help, and operating on assumptions can get us into some pretty hairy situations.
Okay, thank you. There's another one from the audience. This is a great one that we've had brought up many times over the years. Is it recommended for the room where the chamber is located to be temperature and humidity monitored? So not the chamber itself, but the room where the chamber is sitting. Can you tell us about monitoring and possibly control if that's a factor as well?
So there are all sorts of options for secondary monitoring systems. We provide options ourselves. The the alarming and things like that, I suppose, would require another controller, and we may refer to another company that specializes in monitoring things like that. But it could certainly be done. Um, Controlling the space where the mechanical area is, we have a fairly wide tolerance. Um, Even our -20 freezers and full range temperature and humidity units can operate in a fairly wide range of ambient temperature. Jeremy may know more specifically. I believe it's 65 degrees Fahrenheit all the way up to 85 degrees Fahrenheit. So pretty much any comfortable air conditioned space will be okay for our unit. Sometimes we find that a unit will be on a storage container out in a parking lot, in the baking sun. It easily gets above 85 degrees Celsius or Fahrenheit. And at that point, the unit really loses its ability to cool the inside of the chamber. So certainly options to monitor the ambient area around the conditioner itself. Not in my wheelhouse or expertise, but we certainly do work with companies that will install sensors all around the inside of our chambers to validate them. So there could be options to monitor the ambient air as well.
Thank you, Jeff. From personal experience, I know that question has been asked of regulatory officials coming through on inspections. I don't know if they were citing any requirements anywhere, but the question does get asked. There's another follow-up question here. Is there a pharmaceutical guideline for how many temperature monitoring systems should be used on chambers? And in their example, they have both circular chart recorders and a web-based monitoring system where we get our alarms from. So I don't know if you have a recommendation from the viewpoint of parameter, but I can comment on that. But I'll let you tackle that first, Jeff.
So we do offer validation services. In my experience, the validations most often involve 16 sensors, 16 temperature sensors. I don't believe there are as many humidity sensors. We do allow monitoring. The monitoring and data logging through our controller is not Part 11 compliant. So we do recommend an external system. It's not only beneficial for your data retention, sometimes if the temperature probe controlling the unit itself has an issue, then that can provide you false data as well. So the secondary monitoring system is recommended. The number of probes, I do not have a lot of guidance on. I suppose that will be highly application based.
Yeah. In this particular question, I'm not sure they were referring so much to the probes as to the number of monitoring systems. From a regulatory point of view, it's good to have a backup monitoring system. But the bugaboo question that's come up from some of the inspectors are, if they don't totally agree, if they're off by a degree or two in their outputs, which system are you paying attention to? So we've always found that if you have a backup system, do you want it on all the time while the other one is still on, especially if it produces different results? And above all, to always define which is the primary system that you're paying attention to. And under what circumstances do you switch from the primary to the secondary? So if you have all that information and good justification, you usually make out pretty well with the two systems. But you always want to make sure that you've carefully identified that you're not playing the field, as it were, with the data as it comes out, picking and choosing which one you want to follow. So always make sure that you're pointing to the one that's in effect at the time and why you should switch over to the secondary one. I'll leave that one at that, and we'll watch for other questions coming in. In the
Although,
meantime, how about the
actually, I wanted
quality of
to,
the, yeah, Walter?
if I could, just another side to this question. Again, I'm not sure exactly where it's going, but the question of how many probes to have in your chamber at a given time. Um, and in answer to that, there isn't a guideline. However, the question is coming up a lot more from auditors of, why don't you have at least two, one at your lower point and one at your higher point within the chamber, based on the validation results, or the mapping results. Um, if you do only have one probe, so like in your example here, you had a chart recorder and a web-based monitor. If you had both of those pulling data from a single probe, you must at least justify the location of that probe. It could be based on the manufacturer's recommendation. However, based on your mapping as well, you're going to have to show that where we put the probe is consistent with, say, the midpoint of all the mapping or the worst case, etc. Leave it at that.
Mhm. Excellent point. Another one came through, how to limit the ice buildup for a -20 freezer. Would dehumidifier packets be useful, or would that have an effect that would be limited for cold condition?
It would
So
depend
kind of a
on,
defrost question.
it is kind of a defrost question. Defrost is the key. Ice buildup is inevitable. Um, Depending on how many times you open the door, the vapor seal of your chamber, you very much want to ensure that your defrost cycle is well timed, well tuned, and that the drain for that water that's defrosted, or the ice and water that's defrosted off the coil, has a way to get out of the frozen chamber without freezing itself.
Mhm.
A dehumidifier can be useful, but I'm not sure that it would be useful at -20. The amount of water vapor in the air at -20 is likely so low that the dehumidifier would not be effective. Um, the water that ends up freezing on the coil is most often moisture that's introduced from ambient air during a door opening. So unless you were able to catch that vapor right then and there, I don't necessarily think a dehumidifier would be effective.
In this case, he talked about dehumidifier packets, and I'm thinking that's like a desiccant that we put in with a product to keep moisture out. And I think why it could pull some humidity out is probably very variable in its impact. So to say that you control it with something as variable as a dehumidifier packet could bring some regulatory questions.
Mhm.
Just an opinion.
Yes, when we apply industrial dehumidifiers to environmental control rooms, they utilize desiccant, but also a heater to heat that desiccant to increase its ability to dehumidify, because you're basically going below, in a freezer, the frost point, and you're getting down to very low grams of water in the kilograms of air.
While we're on the topic of water, can you comment on what grade of water should be used in chambers that have relative humidity control?
That's a very good question, John. It depends on the theory of operation of the chamber. Um, a lot of environmental control chambers will use a dual pressure system in which they have a dehumidifier as well as a vapor injection. And they will mix those air streams to get the desired humidity. The use of a vapor injection airstream usually requires incredibly pure water, sometimes even deionized water. Um, Parameter units use an entirely different mode of operation we call two temperature or dew point control. We are controlling a water bath to the dew point of the desired condition and then reheating that air to get our preferred relative humidity. Our chambers often work well with just municipal city water. If you find that your municipal water smells of chlorine or isn't terribly well filtered to where you're growing algae inside the saturation chamber, then we recommend RO water. Whereas some of the vapor injection chambers will require deionized water, we actually highly recommend against deionized water because over time, the circulation of the deionized water inside of our process chamber will eat away at the internal components, including the fins of the evaporator coil.
Sounds good. Thank you for that.
Just to clarify, you're saying so like 80-90% of the market is the humidity injection process, right? And that would be typically DI or distilled water. Is that what you're getting at?
I do not know the exact market ratio, Walter, but I do know that a lot of the competitor equipment I see does have a vapor injection mixed flow theory of operation.
Okay, thank you.
Let's see, as we start to wind down here, we're getting close to the top of the hour. What's the ideal location for a chamber room, a room full of chambers? Should it be, often it's found in the basement, sometimes on the ground level, other times it's up near the ceiling, so you can have things up on the roof. Do you have any recommendations for where chamber rooms should be located?
We've put them on the third floors. There's actually a small chamber inside the Empire State Building. We've put them in basements and actually had backhoes dig down into the ground and we demo a wall and build a whole basement full of chambers. It really does not matter because the environmental control chamber ideally has very well insulated walls, and those walls are also very well sealed with a vapor barrier. When we build chambers, they are modular panels, much like a walk-in cooler. And as we are putting those panels together, we take great care with butyl and silicone to make sure that that vapor barrier is very robust. So with the vapor barrier and the insulations of the walls, the only factor that really dictates where you want to put the room itself is that ambient temperature and making sure that it's between the 65 and 85 degrees Fahrenheit that the unit can operate in.
Okay, great. So it doesn't matter as long as we're doing all the right stuff in all the other categories.
Yep, exactly, John.
Okay. I think that's as much time as we have for questions today. I wanted to thank our PG&C panel members and co-host Walter Routh and all those who attended today, especially for your questions. We hope you take away information that will improve or preserve your chamber compliance or bring greater efficiency to your operations. I'd ask that you would please join us again for subsequent programs in Stability Chamber series that we'll have, as well as to our December 5th webinar on sample control. The schedule for these can be found in the events section on StabilityHub.com and in our monthly newsletter. I wish everyone a good day, and we hope to see you again soon.